Howdy folks, welcome back to another Out of Spec Renew video. Today you join me here working on this 2015 Tesla Model S 90D. Believe it or not, this car has actually got nearly 300,000 miles on it, and the owner tells me it's all original powertrain. Never had any of the motors replaced, and the battery pack is also original. I actually looked at the serial number on the battery pack and it does check out. It does look like it's original. But the issue that we're looking at here today is actually a problem with the front drive unit, and that is that the encoder sensor, which basically gives feedback to the inverter to tell it how fast the motor is actually spinning, is faulty on an intermittent basis, really only when the car's quite warm, like say driving at high speed down the freeway for hours on end. So I don't actually have alerts present at this time, but I've looked at the logs and stuff, and it does indeed look like it's probably an encoder sensor failure. If this were a rear large drive unit, it would be easily serviceable. You can just pull the encoder sensor out and replace it. Encoder sensors are a known failure point on these, but it's not super common. But unfortunately on the front drive unit, it's not so easy to replace that because the encoder sensor is actually located behind the inverter on the drive unit, and there's no accessible way to get to it. So as far as Tesla is concerned, for this type of issue, their only fix is to replace the entire drive unit assembly. What we're going to do instead here is actually going to be a little bit of an experimental repair for me. I've never seen anybody that's actually replaced an encoder sensor on a front drive unit. And I haven't confirmed part numbers or anything, but I'm about 95% certain that it's the same encoder sensor that's used on the rear large drive unit, and I'll show you guys why. I want to give a big thanks to our friends at the CCAN Action Fund for sponsoring this video. If you're looking for your chance to drive off in a brand new electric vehicle and support a nonprofit organization, well, one of the best nonprofits that's fighting for clean energy is running their 7th annual EV raffle, and this year is their biggest one yet. You've got amazing odds to win because for the first time ever, there will be 3 prize winners, and there's only going to be 10,000 tickets sold, so you've got pretty great odds of winning. The prizes really are stunning. The first prize winner gets picked between one of 6 different luxury EVs, including a Rivian R1S or R1T, a Porsche Macan EV or the Porsche Taycan, or a Lucid Gravity or a Lucid Air. The second prize winner gets to pick between a Hyundai Ioniq 5 or a Volkswagen ID Buzz. And for the first time ever this year, there will be a third prize winner, which gets to take home a brand new Chevrolet Equinox EV. And even better yet, state and federal taxes are also covered by the organization. The CCAN Action Fund fights for clean energy nationwide, and by supporting them, you could not only win a new EV, but you're also supporting a great cause. So it really is a win-win. To enter, visit www.evraffle.org. Again, that's evraffle.org, or you can visit the link in the description below. Tickets are only $200, so make sure to get yours today. And once again, thanks to the CCAN Action Fund for sponsoring this video. All right, so like I mentioned there in the beginning of the video, it appears, based on everything that I've been able to find, that the encoder sensor on the front drive unit is the same as the one that's used in the rear on the large drive unit, and I assume probably the small drive unit as well. I haven't confirmed that, and there's no published information on whether or not it is the same part, but I've done some research looking at teardown videos and such, and I'm fairly certain, at least I'm almost certain, that it's the same part. This is what the encoder sensor itself looks like. This is one for a large drive unit. If you look at teardown videos, which I'll see if we can insert some screen grabs here of what this encoder sensor looks like in place on a front drive unit, it looks the same. I haven't been able to find any published part numbers for it, but in those teardown videos, you can see the encoder wheel. So this is the encoder wheel, again, off of a large drive unit. And if you look at those teardown videos, you can actually see the part number on the encoder wheel on the front drive unit, and it's the exact same part number for this encoder wheel. So that leads me to believe that this should also be identical as well. To get to the encoder on this, we're going to have to remove the inverter. My original plan on this car was actually going to be to remove the front drive unit from the car, but that involves a lot of disassembly. You have to evacuate the AC system, remove the AC compressor, and basically a ton of labor. But I think I have a theory of an easier way to do it where we can remove the inverter without pulling the drive unit out of the car. Let me show you what my plan is here. All right, so right here we're actually looking at the front drive unit from the bottom on another car that I have in my shop that's had its pack removed for repairs, which you'll see in an upcoming video, hopefully sometime in the not too distant future. But with the battery pack removed, you can see we've got plenty of access here to the bottom of the front drive unit. And it's got all these sound deadening pads around it, but if we can remove those, which they are removable, the inverter is located on this side. And it basically just has a handful of fasteners around the edges, and it's got a 3-phase cover, which I believe is located directly behind here. Yep, there you go, so you can see it right there. And what I think we can do is unbolt those 3 phases, of course, remove our coolant lines and stuff from the inverter, and then unbolt the inverter from the motor and either completely remove it or at least get it out of the way enough that we can gain access to the encoder sensor, which lives behind it in there. So that's the plan. What we're going to go ahead and do now is we're going to go ahead and get back to our other car there. We're going to pull the pack out of it, which I probably won't show in too much detail. I've already shown how to do that in the previous videos. But once we get the pack out, we'll go ahead and try to remove the sound deadening cover, clamp off all of our coolant lines and everything, and try to get to removing the inverter from the drive unit. Alrighty, as always, we want to make sure to get our high voltage system disconnected, so we'll go 12 volt first here. There's the 12 volt battery disconnected, and now we can remove our high voltage disconnect. There we go. We'll put that back there. And now we can go ahead and drop the pack. Alrighty, our high voltage system is all disconnected. Now it's time to go ahead and drop the pack out. Like I said, I'm not going to go too into detail on this because I've already showed that before. So yeah, we'll just get this thing dropped out here real quick. Shouldn't take very long, maybe half an hour, give or take. And then we'll have access to the front drive unit there. Alrighty, so as you saw there, we got the pack out. And now we've got access to our front drive unit here. I think what I'm going to do first is I'm actually going to lower the car down. That way we can get access to it from the top side, and we might have to remove the 12 volt battery or a couple of other things to kind of get access to pull this cover off. But I'll try and unhook whatever Velcro I can here from the bottom. And then, yeah, I think I'll continue this process on the top side. We've also got to undo our high voltage cables, which I'm not sure if that's going to be easier to do from up there or down here. Yeah, I'll have to take a look at that when I bring the car back down. And then we, of course, also have a data connector up there we need to unplug too. So bring the car back down and we'll take a look at it from the top side there. All right, we've got the car back down. I'm going to go ahead and pull the 12 volt battery out here, along with its bracket, just so we have a little bit easier access. So I'll just go ahead and undo our positive terminal here. Okay, got that out of the way. And I'm actually just going to leave the battery in its bracket. No point in removing it, since we're taking the whole thing out anyways. All right, I think we should be free there. And indeed we are. All right, yeah, that gives us way better access here. So I can undo some more Velcro. I don't know if I have another one on top here. I don't feel one, but there might be. But I think that our next order of business is probably going to be to remove this coolant hose and get access to our high voltage cables and our data connector, which lives kind of right up here on top, sort of under this cross member. Let's see if I can bring you guys in and show you that. So that right there is our high voltage cables. Those still might be easier to access from the bottom, but I might try and get them from the top here while we're in here. And then the data connector is right down there, so kind of just below this coolant pump right here. And yeah, so shouldn't be too difficult to get all that stuff unplugged. Let's go ahead and do it. All right, so I clamped off our other coolant hose from the bottom there, and I'm going to use this one right here on the top side because I want something that's kind of compact and will fit in here rather than the sort of vice grip style. Those ones sure are handy, but they just take up a lot more space. We're clamped down pretty good there. Now to try and get, I don't know if I can get these pliers on there actually, so let me grab some different ones. A little bit too tight of a gap in there to get those other pliers in, so I'll just have to go with the standard vice grips, or not vice grips, but channel locks rather. Of course, now my problem is that I can't get it clamped open far enough to get it past the end. So close. There we go. Let's see if we can grab that hose and just give it a little twist. This is a plastic nipple that it attaches to, so we don't want to break that, obviously. Sweet. We'll just kind of tuck this hose up here where it's out of our way. And let's see what other covers here I have to unvelcro. Oh yeah, there we go. Okay, so I think we got that stuff mostly undone here, but of course we still need to undo our other connections. So let me see if I can get that stuff undone here. All right, as you can see, we're back under the car. I did undo the data connector on the inverter. Because it's such a tight spot in there, it's basically just impossible to show that while also doing it, but got that unplugged. Now we're gonna undo our other coolant line on the inverter here, and I think it's gonna be easiest to take the high voltage cables off from the bottom here. Either way, the access is a little bit tight, but I think it'll be easier to do it from the bottom than from the top. So let's go ahead and get this coolant line off of here. Of course, the battery Rapid Mate is dripping on me the whole time, so that's fun. We'll be all right, though. Just don't want it to drip in my face, if possible. Don't want coolant in my eyeball. That's never fun. Okay, hose is off. Give it just a little twist to try and break it free, perhaps. There we go. I think we're good there. And now we can pull that hose off. There we go. Lost a little bit of coolant there, but not too bad. And once again, I'm just going to tuck this hose back where it's out of our way. That should be good. Awesome. Now just to get the high voltage cables off. All right, this is going to be tricky. I don't even know if it's possible to fit this thing through here. We'll probably have to try and kind of bend it around and whatnot for sure. But can I actually get it fully out? That is the real question. I think I have an idea. I think if I cut a couple of slits in it, where it just has a flap that can move, we should be able to pull it out from the bottom. And that'll do it. I don't usually like modifying stuff like this, but this is just an acoustic cover, and we can stick it back on there and fold that flap back into place, and it should be all good. All right, so I think I'm gonna cut a flap right here. Yeah, I think that should make it way easier for that to fit around. Actually, if I go just a little bit further, I can actually go around the coolant nipple on the inverter here. Only got about 3/4 of an inch to go there to do that. Yeah, there we go. That gives us way more flexibility with this thing. Let's see if I can get my arms in here. Oh, I forgot something very important. I didn't get our ground cable, so we are getting hung up on that. And this right here is actually a little fuse holder that's getting in my way as well. Try and see if I can pop that out of place. The wiring harness that comes out of the bottom of it is actually interfering here. But I should be able to basically slide that off of its mount here. There we go. Now that's out of our way. Okay, so I gotta kind of push this back. Can I even get to that ground cable connection? Can't really get to it on the inverter side, so I'll have to unbolt it from the body, which is fine. I think it's a 13mm nut. Yeah, we're pretty close here, but I think I've got to get at it from the bottom where I can get a bit better grab on it and pull it out from that end. But I think we should be able to just kind of pull it out of here. And hopefully that's not too much of a chore. I might cut another slit on the flap from the bottom side as well to make that a little bit more pliable. All right, back up we go then. Alrighty, well there's our acoustic cover removed. And now we can see the actual inverter housing here. So you can see it's just got a bunch of fasteners around the edges. And of course we have our 3 phases right there. So we'll have to disconnect our 3 phases. And then there's a connector on the inside here. When we unbolt this and start to pull it off, we'll have to unplug a connector from the back side of the inverter that goes to the encoder sensor as well as a stator temperature sensor. But first, let's go ahead and get those 3 phases undone. All right, so to get our 3 phases off, we've got 2 screws under this sticker here. I assume they're going to be T25s, which is what is normally there on a large drive unit, but I'm basically just going to try and puncture through the sticker. Is it a T25? I might have to peel the sticker off, I guess. Oh no, they're not. They're M8s. Alright, we'll just pull the whole sticker off. Uh-oh, warranty void. Doesn't matter anymore on this car. It's far outside of warranty. Alright, let me get an 8mm socket and we'll get those pulled. There we go. Alrighty. Let's see if we can get that cover off of here. I should be able to just pry up on the edge here somewhere. And boom, there we go. So our 3 phases are in there. Those look like, are those 11mm bolts? Bolt heads? Kind of looks like it. They might be 10s. All right, let's go ahead and get those unbolted next. All right, so these are indeed 10s. So we'll go ahead and get those loosened off. I think once I get them loosened with the ratchet, I can pull them out by hand with the socket by itself. Let's see, I'll at least give it a shot. All right, there's one. Whoa, I keep bumping the camera there. Ooh, this one's a little too tight to get out by hand. All right, I'm gonna have to move the camera because it's kind of in my way here. But anyways, I'll bring you guys back once I get the rest of those out. Alrighty, our 3 phases are unbolted there. Now all that's left to do is to take out the fasteners around the periphery of the inverter casing, which these are all just 8mm heads. And yeah, so I think I'm just gonna run through all those real quick. Some of them are kind of tight to get to, like there's one way up here right next to this motor mount. But I think I can get to that just with an extension and a regular ratchet. And yeah, so I'll probably have to do a combination of both down below here as well as up above to get to them all. And then we should be able to just kind of pop that thing off of there. I'm not sure if there's enough space to totally remove the inverter completely. If I can, I will, which it'll have to come down through here. This is really the only place where it would fit. But I don't know if we can push it far enough that way to actually get it fully out of here. So it might just have to be unbolted and kind of moved out of the way to get to the encoder. And we might not actually completely remove this thing. So it might kind of stay sort of in place. We'll just unbolt it and split the case enough that we can get in there. Yeah, let's get to it. All right, so we're fully unbolted on the inverter here. It actually has just a gasket on it. It doesn't use silicone or anything to seal it on there. So we should be able to just kind of gently pry against the motor casing here, and it should just kind of pop out of place. So I'm just going to try and find a good spot where I can just get a little bit of purchase under it. And I'm just using a screwdriver because I want to use something that's thin. Oh, there we go. That was easy. All right. So that is off. And I don't know how well you can see up in there, but those blue wires up here near the top, that's the wiring for our encoder sensor and for the temperature sensor. So I'm going to go ahead and try and unplug that from the board, which might be easier said than done to fit my fingers in there. Well, it's not so bad. Okay, so I'm just going to reach in there and unplug that from the inverter. Of course, it'd probably be beneficial if my hands were actually clean. So I'll try not to touch any of the electronics if I can. All right, so that's unplugged, so that's our harness right there. Let's see if I can get this inverter out of here. I might actually be able to. Oh, heck yeah, that's not so bad. It's a little bit of a tight squeeze, but I think I can get it past the steering shaft here. I just want to make sure I'm not hitting any of the electronics here. Yeah, I'm almost out. I'm just kind of hanging up on the outer casing a little bit. Oh, I see where I'm stuck. I'm stuck on this motor mount bolt. Okay, can I push this back up in there? All right, I'm gonna have to probably struggle with this for a minute, but I've just about got it out of here. There we go. On the other side of that bolt. There we go. There went our light, but we got the inverter out. So let me just set this off to the side. Alrighty, folks, we're back at it again here after lunch. Let's go ahead and remove our encoder sensor here. So we're just gonna pry that tab up just a little bit on this connector and just kind of give it a little bit of a wiggle, and it should come off of there. There we go. And then we've got one screw that holds the sensor in. We'll get that unbolted. There we go. Now we can remove the sensor itself. And bingo, there it is. Oh, interesting. So we've got a little bit of oil in here. I wonder if the seal on the back side of that is leaking. We might want to pull that cover off and take a look in there and see what's going on. All right, I had a phone call come in there that I had to answer, but we're back. I'm going to pull the cover off of here and we'll take a look and see how things are looking behind here, because we definitely had a fair amount of oil on that sensor. Let me get a longer socket. Can't quite fit my tool in there. Let's try and pop this cover off. Ooh, yeah. That's pretty gross. That may well have been what our problem was there. Let me get a better light in there so we can get a better look at that thing. There's also some metallic material in here that seems to be built up. But yeah, you can see just how dirty that is. You can see if I wipe that off, see how much shinier the gear is where I wiped it off, or the encoder wheel rather. That's all metallic buildup. And actually, if we look at the encoder sensor, there's metal on that as well. I'll show you guys. All right, so this right here is the encoder we pulled out, and of course that's the cover. But you can see this is metal, and this sensor is actually magnetic. So we've got metallic material sticking to the sensor here. Oh, and also right there as well. So that might have been part of what was interfering with this, but it was working fine most of the time. Just when it got really hot was when it would start to develop issues. Oh, whoops. I dropped the new one there. But if we compare the new one and the old one, they are indeed the exact same part numbers. So they are the same parts. That's probably like a serial number on that side. But yeah, that's it's no bueno there. And then of course our cover here is full of oil. And we've just got all sorts of metallic schmutz in here. I don't know how long this seal has been leaking for. Yeah, I don't know if it's feasible to try and replace that seal or not. And this customer is on a bit of a time crunch. They actually drove this car here from Wyoming for me to work on. And even if I can replace the seal with the drive unit in place, I don't know if I can get one in time to put this thing back together for them. So we might have to do a little bit further digging here. I mean, I'd really hate to just clean this up and put it back together for fear of it causing more issues later. But depending on how slow of a leak it is, it might be functional for a really long time. Of course, like I said, this car does have almost 300,000 miles on it, and this thing's been untouched. So who knows how long it's been leaking for. It may have been like this for the last, 100,000, 200,000 miles. Let me do a little bit more investigating here and see if I can find anything as far as the size of that seal. If it's the same size seal that's used in the gearbox of the large drive unit, I might have one in stock that I can stick in there. Made a bit of a mistake here. So this motor actually doesn't have any seal between the encoder housing and the rest of the gearbox. It's actually just open through a bearing cage. So it's actually perfectly normal for there to be oil in here. I suspect what may be happening though is that the amount of wear in the gearbox has just caused metallic material to build up in the oil, and it's built up on this sensor over time, and maybe this is interfering with its ability to measure the teeth on the reluctor wheel as it goes by at higher temperatures. I'm still going to replace the sensor with a new one because it is still entirely possible that this is defective. And we're probably also going to replace the gearbox oil in here. Obviously, we've got metal in the oil, and it's definitely fairly dirty. I mean, it's actually, I don't know how well you can see that on camera, but it's actually still pretty transparent. But it's definitely dirty, and I would bet that this oil probably has never been changed in the 290,000+ miles that this car has on it. So definitely something that we want to do. I suspect that if the oil had been changed a little bit more regularly, say maybe every 50 or 100,000 miles, we probably wouldn't have had this metallic goo build up on the sensor. In any case, I'm going to go ahead and get this stuff all cleaned up, and we'll get it all put back together, and of course we'll change the gearbox oil as well, probably after I get the inverter and everything back on. So yeah, let's go ahead and get this put back together again. All right, I got everything all cleaned up. Reinstalled our cover for the encoder wheel here. And now I can install our new encoder sensor. I think that's just about fully seated in there. And now we can get our bolt in. And there we go. Now we can go ahead and get the inverter back on here. Alrighty, inverter going back in. Oh, don't want our ground cable to get caught up there. So we're going to very carefully try and slot this in. Okay, I think I've got those threaded in just enough that that's not going to move, hopefully. Let me try and get a tool on those so it's a little bit easier. It's real hard to try and tighten those bolts up by hand, especially because they're tiny and there's not much clearance. There we go. That's way better. Okay, now I've just got to go around and get the rest of those all tightened up. It's pretty much all the ones I can get, at least from the bottom, besides one more, but I can't get that one with the power tool. I need to do that one by hand because it's a little bit too tight a clearance. So yeah, I'll get that one in, and then we'll go up top and get the rest of the bolts installed. All right, the inverter is fully bolted on. Got all the fasteners here on the back side as well, as you can see through the little gap there. So we're going to go ahead and bring the car back up. We'll connect our three-phase connections from the inverter to the motor, and then I think we should be ready to put our acoustic cover back on. Alrighty, as you can see, I got our three phases reconnected here. The sticker is actually still pretty sticky, so I was able to basically just put it back on there. If it hadn't been sticky, I probably would have just put some glue on it to keep it in place, but it's basically just a high voltage warning thing. It's not a critical component to be there, but I like to keep the high voltage warnings on components if possible. So now we can kind of just tuck this back into place where it's supposed to go. It's actually supposed to tuck under this a little bit. And yeah, that's about right. So I think I'm going to go ahead and change the gearbox oil real quick. I probably won't bother showing that since I've already got a whole video showing how to change the gearbox oil on these. I guess technically this is a different front drive unit than the other one I did. This one you don't have to run the pump or anything to fill it. But yeah, I'm basically just going to drain and refill the gearbox fluid on here. I'll do the same on the rear one here as well, but yeah, I'm just going to go ahead and get that done because I want to try and get this car running by the end of the day, hopefully. Alrighty, we've got the drive unit fully assembled. I changed the gearbox oil. We've got all the acoustic covers and everything back on. Now we've just got to get the battery pack back into the car and make sure that everything works. Alrighty, I do believe we've got pretty much everything reassembled here. Pack is in, drive unit is all put together. I think we're good to go to try and start this thing, so let me get the high voltage disconnect here. We'll get that attached where it belongs, just like so. And then we'll get our 12-volt battery reconnected here. Oh, I hear contactors. That's a good sign. Coolant pumps are running. We will have to run a purge routine, although I don't think we lost that much coolant since we clamped off the lines. That's the handy part about using those coolant hose clamps, is you can avoid losing a ton of coolant. With the battery rapid mate dripping the whole time and whatever we drained out, I would say maybe a quart-ish, if even that. But yeah, let's go ahead and start this thing. Alrighty, moment of truth. Let's hop in this thing and make sure that we go into drive. Indeed we do. We get drive in reverse. Don't have any alerts present other than just tire pressure monitoring and whatever other miscellaneous stuff. Let's actually go into service mode here. By the way, 292,000 miles on this car. We'll go service. Yes, we would like to enter service mode. And of course, as you can see, we've got all of the glue leaking out of both the MCU and the instrument cluster. So those are also some other things we're going to do while the car's here. The guy actually had a Model X that he did an MCU2 upgrade on, and he was able to save the old MCU and stuff. So we're actually going to swap the screens over from that MCU and instrument cluster, which is a pretty straightforward job. Yeah, of course, we've got typical shutter no feedback, TPMS fault, one of the HVAC actuators. That's all normal stuff to see. Nothing major. So, yeah, sweet. Hopefully this holds up for the long term and doesn't have any more faults for the front drive encoder. Sweet. Alrighty, well that's a wrap for this one, folks. Of course, I do still have some other stuff that I need to get done on the car, but that wraps it up for the front drive unit encoder sensor replacement. Yeah, this was a pretty interesting experiment to do on this one. I wasn't 100% certain that I actually could get the inverter out that way, but it certainly looked like I could, and it saved a heck of a lot of labor time versus removing the whole front drive unit. Probably somewhere on the order of like 4 or 5 hours of labor. To pull the front drive unit, we would have had to take apart all the front suspension, evacuate the AC refrigerant, remove the compressor, and a whole bunch of other stuff in the front area under the hood here. So dropping the pack is super easy. On this car, you know, pulling the pack out takes maybe half an hour, 40 minutes. Putting it back in is a little bit more time consuming just to get it all lined up. But, you know, again, we're talking, you know, maybe 45 minutes to an hour, something like that. So yeah, that's a job done on this one. It's a pretty uncommon failure, I think, but it is enough of a known failure that I have seen encoder sensors fail, usually on the large drive units. But yeah, this is my first time seeing one on a front drive unit, and it's good to know that the replacement is indeed just the same exact part that the large drive unit uses. So anyway, that's it for this one. As always, thanks for watching.